Welcome to qnawire.
Okay, so we're going to draw a diagram here. So let's say this is the object from where light rays are coming out. So I'm going to draw two light rays. So when they hit the surface, then they're going to refract, and these are going to be the refracted rays. So here I have my theta 1, and this angle here is theta 2. So what I'm going to do is I'm going to say that this side of the triangle, you see there's a right triangle here, is the actual depth. And if I say this distance is x, I can also extend another line here. And therefore, I can say this angle here is also x. So that's one part. Then if I retrace this ray of light back to where it's going to come and hit here, then this is going to be my apparent depth, because the other ray of light is also going to come and intersect at that point. And then this angle here is theta 2. And if this angle is theta 2, then this angle here is also theta 2. So now we are actually ready to go back and start with Snell's law. So Snell's law says n1 sine of theta 1 is equal to n2 sine of theta 2. And then the question tells me that sine of theta is approximately the same as tangent of theta if theta is small. So I can rewrite Snell's law as n1 times tangent of theta 1 is equal to n2 times tangent of theta 2. So n1 times tangent of theta 1. So for theta 1, x is the opposite and d is the adjacent. So tangent of theta 1 is equal to the opposite over adjacent. In the same way, n2 times for the angle theta 2, x is the opposite and d prime is the adjacent. So that's going to be x over d prime. Well, I can cross out the x on both sides. I can divide both sides by x, and then I can cross multiply. So I get n1 times d prime is equal to n2 times d, and that gives me d prime is equal to n2 over n1 times d, and that can be written in the form that's given in the question, which is d times n2 over n1.